In this video, I will show you how to integrate using natural logs. And this fact over here in the corner is the one that you need to memorize in order to solve problems like this. The integral of 1 over x equals the natural log of x. Solve the differential equation whose solution passes through the given point. This is a differential equation because it has a derivative in it. In order to get y by itself, that's what it means to solve the differential equation, I just need to integrate both sides of the equation. If I integrate the left side of the equation, I immediately get y by itself. Now I just need to integrate the right side of the equation. Before I actually integrate, I'm going to rewrite this to make it easier to understand what to do. So I'm using, whoa, that's not a very good integral sign. I'm using what I often refer to as the a plus b over c principle. I can split this up as a over c plus b over c. So in this case, I can split this up as x over x minus 2 over x. You can see that x over x is the same as 1, and 2 over x is the same as 2 times 1 over x. So now I'm going to integrate term by term. So the integral of 1 will be x, and then when I get to the next term, I see that negative 2. I'm just going to leave the negative 2 alone, and I'm going to integrate the 1 over x. But remember, I told you, the integral of 1 over x is natural log x. So I'm going to have 2 natural log x, and then the constant of integration. So we are almost done, except for this c value. All we need to do is find out what the value of c is. And they gave us a point, negative 1 comma 0. So we can use that to find c. You know what? I left out something very important when I gave you the rule to memorize. This should be natural log of the absolute value of x. You can't take the log of a negative number. So it is very important that we have the absolute value in this formula. So that changes my equation a little bit. I now have x minus 2 times natural log absolute value of x plus c. Now we just need to find c. They gave us a point on the curve. So all we need to do is substitute negative 1 for the x's and 0 for the y. So we will get 0 equals negative 1 minus 2 natural log absolute value of negative 1 plus c. Please do not make the mistake of combining the negative 1 and the negative 2 right now. We must follow the order of operations. So we can go ahead and simplify. The absolute value of negative 1 is positive 1. So maybe I'll just do that to make it really clear that we have 1 minus 2 times natural log 1 plus c. We know that the natural log of 1 is 0. If you did not know that, memorize it right now. The natural log of 1 is 0. You have to know that. Anyway, so if the natural log of 1 is 0, then this term is going to be 0. So that just leaves me with 0 equals negative 1 plus c. And adding 1 to both sides, we get c equals 1. So now we can finish up the problem by substituting 1 back in for c. Kabam! This is the solution to the differential equation. To solve this differential equation, I need to get r by itself. So I will integrate both sides of the equation. If I integrate the left side with respect to t, that just immediately gives me r equals. Now I will integrate the right side of the equation, but I'm just going to show it step by step. Here comes some good old-fashioned U-substitution. Let's let U equal the entire denominator here. So we have U equals tangent t plus 1. We will need U prime. So the derivative of tangent is secant squared. So that's U prime. Let's go ahead and make that substitution. So I have R equals the integral of secant squared t over U. We replace dx with du over U prime. In other words, du over secant squared t. But we immediately see that we have secant squared t in the numerator and the denominator. These will cancel each other out, so these are gone. Now we have R equals the integral of 1 over U du. So we have memorized that the integral of 1 over U is natural log U. So I now have R equals natural log, well, absolute value of U. Let me not make that mistake again. Plus C, the constant of integration. Replacing U with tangent t plus 1, we have this. Now let's find the value of C. So let's substitute pi in for t, and let's put 4 in for r. So we have 4 equals natural log absolute value of tangent pi plus 1 plus c. Tangent of pi is 0. So that's going to be 4 is equal to natural log absolute value of 1 plus c. The natural log of 1 is 0, so we just have c is equal to 4. Now I'm going to take this red equation and rewrite it with 4 in for c. So I have r is equal to the natural log of the absolute value tangent t plus 1 plus 4. And this is the solution to the differential equation. For number 46, we need to solve a differential equation that involves f double prime. That means that ultimately we will have to integrate twice. So let's get started. If I integrate the left side of the equation, f double prime becomes f prime. So I will have f prime of x equals. Now I need to integrate the right side of the equation. So I have the integral of negative 4 over x minus 1 squared minus 2 dx. Let's split this up into two separate integrals. So now we have this. I think it will be better if we take this negative sign and bring it out in the front, as well as bringing the 4 out in the front. So let's have a negative 4 in the front. Now it is time for some U substitution on this part only. So let's let U equal the x minus 1. And, well, U prime will just equal 1. So this should be pretty simple. So now we have this. And of course, 1 over U squared is the same as U to the negative 2 power. So feel free to skip this step and go straight to this. It's time to integrate. So we have f prime is equal to, I'm going to add 1 to this exponent. That makes negative 1. And then I divide by the new exponent. So I'm dividing by negative 1. That's going to end up turning this negative 4 into a positive 4. So now I have 4u to the negative 1 power. And then the integral of 2 is 2x. So I have minus 2x plus c. Remembering that u is x minus 1, we now have this. It's time to find the value of c. Looking back at the setup, they gave us the value of f prime at 2. F prime at 2 equals 0. Let's use this to find c. Let's start by setting up f prime at 2. F prime at 2 will be 4 times 2 minus 1 to the negative 1 power minus 2 times 2 plus c. Since we know that f prime at 2 equals 0, we can substitute 0 for f prime at 2. Let's simplify on the right-hand side. So I have 4 times, this is 2 minus 1 is 1. 1 to the negative 1 power is still 1. And then minus 4 plus c. So 4 minus 4 is 0. So this is just c equals 0. Let's go ahead and rewrite the original equation that we found, putting in 0 for c. So here is the equation for f prime. Let's just rewrite this without the negative exponent. And here it is. In order to solve this differential equation, we need to integrate again. So let's integrate both sides of this equation. Integrating the left side gives me plain old f of x. On the right-hand side, I am integrating term by term, and I've chosen to leave the constants out in the front. So we now have this. If we let u equal x minus 1, we have this. But here comes the memorized rule. The integral of 1 over u is the natural log of the absolute value of u. Adding 1 to this exponent, I get x squared, and then I divide by my new exponent, but that's 2 divided by 2, so the 2 cancels out. And then I just have plus c. Remembering that u is x minus 1, we have this. All we have to do is find the value of c. Let's look back and see what they told us about f of x. In the setup, we were told that f at 2 is equal to 3. So let's set up f at 2. So we have natural log of 2 minus 1 minus 2 squared plus c. But remember, f at 2 is 3. So let's substitute 3 for f at 2. So 3 is equal to 4 times the natural log of, well, this is just 2 minus 1, so this is natural log of 1. Don't need the absolute value. Minus 4 plus c. We know that the absolute value of 1 is 0, and 4 times 0 is 0, so this term is 0. So now we have 3 is equal to negative 4 plus c. Adding 4 to both sides, we have c is equal to 7. Let's substitute 7 back in for c right here. So this is the solution to the differential equation. Before I move on to the next problem, let me say two small things. First of all, I went ahead and replaced all of my c's with d's because in a previous step, I already used the variable c as the constant of integration. So I need a new variable because this is a different constant. So I called it d. Also, in the setup of the problem, they told us that x was always greater than 1. Because of that, we don't actually need the absolute value here because we don't have to worry about having a negative number inside the natural log as long as x is greater than 1. It's fine if you put the absolute value. I just wanted to mention that you don't need the absolute value. Aw, shucks. Here we go again. Let's integrate both sides of the equation to get y by itself. So immediately I have y equals the integral of natural log x over x dx. Let's do a u substitution. Let's let u equal natural log x and see what happens. If u equals natural log x, then u prime will be 1 over x. If I make the substitution, I have u over x. I will replace dx with du over u prime. So du over 1 over x. Notice that if I multiply straight across, I have x times 1 over x. These will cancel each other out and make a 1. Let's integrate. So increasing the exponent by 1, we have x squared. And dividing by the new exponent, we have 1/2. And don't forget the constant of integration. Remembering that u is natural log x, we have y equals 1/2 natural log x squared plus c. Let's see if we can find c. X is 1, y is -2. So we have -2 is equal to 1/2 natural log 1 squared plus c. However, we know that the natural log of 1 is 0. That makes this entire term 0. So we have c equals -2. Let's put this back in for c right here. This is the solution to the differential equation.